of data science and web development, software development at French IT companies Inetum and MSA respectively. So, second please. And which actually partly influence our choice of technology. However, the topic itself we are presented today is our proper initiative. So for me, from my side, it follows the discoveries about music harmony visualization I made in my PhD in computational musicology, and with my recent quest on how it actually works and how it's applicable to the AI. And for Summer, it embraces his previous experience in building VR applications. So in this presentation, we will be sharing our experience in AI learning assistant building in the context of a VR application, especially designed for music harmony learning. So about the context. A contemporary stage of development of distance education and in other domains, as we saw in our morning session at EVA, involves the use of artificial intelligence. So, which is actually capable to respond to the increasing need in the individualization of the learning strategies. Thus, we have, for example, chatbots. We have the textual smart chatbots, which can sort out the textual or theoretical information to the provided question by the user. Or we have the system with the visual recognition that are used that can analyze the students' facial landmarks and kind of understand whether the question or the theoretical material is quite explicit for the user or not, in order to somehow correct the learning path. So can we imagine in that context an AI assistant that could analyze the student's activity and generate the test content according to the gathered data? Actually, in this presentation, we will show our practical implementation of this theoretical idea, specifically in the VR application for music harmony learning. So, the application itself relies on a specific way of music sequence representation as a system of graphs. Sam, can you please show the system? Yes, thank you. A system that was created following two main goals in the modern strategies of representation, such as systematicity and memory externalization. So having understood the logic of the construction in the system, we no longer need to memorize it. I mean, we no longer need to memorize the patterns in it. We can reconstruct it using this logic. So it greatly facilitates the harmonic problem solving. And the possibilities of variation, this harmonic variation we can provide in it. Another visual strategy used in the VR application is the augmented score representation, which uses the color and shades to explicitly indicate the function of the chord and structure. So here we have the chord, which are grouped by the subdominant or dominant or tonic function, which is actually particularly helpful when working with the chord inversions in an open position. So both of the strategies, the system graphs and the augmented score, were tested in previous pedagogical experiments, showing great efficiency in knowledge assimilation by students. Here we see the graphs only from one experiment, but there are three of them, and we see that overall assessment and quality of knowledge have been greatly improved. The blue actually indicates the experimental group when all those technologies were applied. And the control group, it's a standard form of representation that did not involve any of those visualization strategies. Thus, the current application is a continuation of the previous experience, following, allowing more interaction and integrity of the learning material presented in a new VR format. So let's make a quick tour through the application.
Yes, hello everyone, and thank you for having us. As mentioned before, the application runs on a VR device. It was initially developed for the Oculus Go, and now it's being modified to run on the Oculus Quest device. Here's some examples. The user experience starts in an entry space, which is followed by a special room called the Temple of Knowledge. The Temple of Knowledge space is a VR room which contains explanations and illustrations of some music theory basics necessary for this experience. It contains elements of the chosen visualization strategies like the system of graphs, the vertical and horizontal triads, as well as the usage of colors and shades. This VR space contains 8 walls. Each one has an explanation card, so the user can navigate through explanations by pressing next and previous buttons on the top of each card. After studying these explanations, the user can go to the next room, which is the core application part. It is called the study room. The study room has an interactive system of graphs with two modes of content exploration, horizontal triad and vertical triad. Each of these modes can be explored in a guided or a free way. In the guided way, the user follows the highlighted elements, as we can see here. The highlighted elements that are actually proposed by the application. In the free mode, he can freely select the vertices and listen to the sequences and freely interact with them. The horizontal triad mode allows to explore an individually chosen graph. It focuses the attention on passing chord variability potential. The chords are represented as the edges in the structure of the graph. The variability potential is followed by an augmented score representation. It puts in evidence the difference in audio representations between the different between the different passing progressions. Next, the vertical triad. Yes, here it is. The vertical triad mode gives the possibility of the entire vertical triad exploration, which reveals the potential of variability for the 7 chords and their inversions. As in the horizontal triad, the user can interact with the edges. He can trigger the score appearance along with the animation. And the choice of the edge should be made in a corresponding graph of the vertical triad. The spatial sound is provided to reinforce distinguishing the chord sequences. This feature is introduced in this VR context. It is expected that it will help the user for memorizing harmonic patterns. Spatial sound is provided, yes, said that. Finally, a testing mode allows us to access an AI learning assistant. It will generate the 3rd chord for the harmonic progression. It looks for the sequences that the user least listened to, so it helps him to complete their learning gaps. Let's see how this assistant generates the content. The content generation is made by a pre-trained AI model deployed on a Heroku server. The communication between the VR device and the server is made via a Flask framework. The data is transferred in a JSON format, and the VR application sends 2 chords from the sequence of the graphs and receives the 3rd chord generated by the model as a response. Here's an example of the used REST interface. The request is given as a query param. The response is given as a JSON object. It contains the predicted chord and the status of the request, like a success, for example. As you mentioned before, the predicting is made by a pre-trained model. Let's have a look on it.
Yes, okay, right. So the generative model itself is based on the long short-term memory, or LSTM, deep neural network architecture built in Keras framework. The model inputs required text format and outputs text data as well, which is actually needed for our JSON. So let's see how the training process looks like. First of all, we read the text file containing all the harmonic sequences we'll be training the model on, transforming the data to a tokens array. After that, we build a nested array where each of nested arrays contains one harmonic progression. Then we are transforming the textual data to a numerical representation. Receiving the vocabulary size, here is actually the transformation, vocabulary size of 47 chords. Those numerical arrays are then transformed to number arrays, which allows us to separate the third chord and to make a prediction target of it. Those targets are then transformed to a sparse matrix. Here we have a sparse matrix on the screen. And in such a form are fed to a sequential Keras model consisting of one embedded layer, two LSTM layers, and two dense layers. After the training process finishes, the trained model is exported to H5 format, and in this stage is ready to be integrated to the Flask project and deployed on the server. So having understood how the whole process works, we can now see what the end user result looks like.
So about how the testing mode is used. When the VR application receives the prediction of the third chord from the AI model, it plays the corresponding harmonic progression. Then it asks the user to choose between the bottom tops of the graph. If the user chooses the correct graph slot, the chord is rendered in an augmented score representation. But in case of an incorrect answer, the user receives feedback from the communication board and the correct chord is not revealed. The user can again generate the question to work towards a correct answer.
Yes, perfect. Summarizing this VR application supports learning process with augmented tangible 3D objects of chords, a system of meaningful color scheme and shades, and proposes a level of abstraction in the form of the system graph, which puts in evidence the relations between chords in given tonality. The AI assistance is used to generate new content for tests rendered by VR applications. It was mentioned actually, it was, well, we told about the, during the presentation, but it's also important to say that the internal algorithm actually analyzes the student's activity. So if student chosen, for example, free mode and skipped some sequences, actually from those sequences, there will be the test questions. So somehow forcing the user to fill those gaps and to go to learn those patterns. And the AI assistants, yes, so thus the VR content together with AI model allows realizing the activity-based approach in music harmony learning with a high degree of immersion, which contributes to the development of music ear and to the enrichment of the learner's cognitive experience in general. So what are the perspectives for this work? Among the perspectives, we can mention at least 3 of them. So the first one is the addition of a creative module, where the user can control some of chord elements, leaving the AI model to generate the rest of the sequence and visualize it in a 3D space, using the presented strategy of graphs and augmented score. Such a module will be an implementation of AI assisting music composition in a semi-supervised mode. So instead of only one chord generation, we could generate a sequence of it, and given the input parameters, a specific input parameters given by the user, visualize it to the VR application. Another axe of development is the addition of the possibility to build the chord of individual notes for better understanding of a chord structure in learning and test modes, and with the possibility in Quest actually to vibrate when we touch something. We can expect more immersive experience actually on that, and expect also other forms of mediation, so not only sound, not only visual, but also touch experience, which should actually expect that it would contribute to augmentation of the learning efficiency. And finally, we expect to build a reward system, introducing some game elements that are quite widely used nowadays, and that also enhance the user engagement to the activities, and in our case, learning activities proposed by the VR application. So this will be all for us. Thank you very much for your time and attention.
Thank you. Can you hear me now?
Yes.
Oh, good. Okay. So thank you, Anna Shvets and Selma Darkazanli, for this wonderful talk. I don't see any questions on the chat box. Does anyone have a question that they would like to ask about this system? Ah, here we have a few things. All panelists. Can everybody see the, does everyone have the chat box open? So we have a nice comment here. And what does the VR environment offer that is not available in 2D digital real world representation? And the second part of that is, did you consider using a Tonets representation which might exploit the dimensionality? And C, what other VR music theory applications are you imagining? That's a big question for 2 minutes.
Yes, okay, it's okay. I think I can handle that. So that the environment might offer, well, actually we have tried to show that, first of all, we are already giving the possibility of the spatial sound. So we have the graph, which has actually graph which have edges. And when you, well, now the sound not really worked here, but when you have 3 vertices and the sound comes actually from left to right, from different sources, so it can actually help to memorize things. Another thing that actually we mentioned in perspective, which is evident and cannot be skipped, that you can actually touch the object. So you are introducing another medium of memorization. So it can be actually done in other, let's say, format than this one. Also, yes, I actually had a few systems that web application or in Android mode. I actually built some Android application which partly implemented the system. But what we have here in VR application is everything in one place. I mean, the immersiveness of the whole experience. So you have your graphs, you have your visualization board, you have this notion of space. You are separated from the distraction, let's say, world, and you're really focusing on the learning material itself. So there are a few things, but I think that those I mentioned are the most crucial, at least were the most crucial for us when we were building this experience. Did you consider using tonings? Yes, of course. I knew, of course, tonens as a system of representation. The problem of tonens that it's not a tonal based. So usually it proposes you the different chords like minor third or major third, but in the learning experience, if you if you're teaching the harmony to students, you are giving it to a certain tonality. So in that given tonality, you have this notion of function, tonic, subdominant, dominant, and related chords. You don't have it in tonance. So in tonance, you just have chords organized some way, but there is no notion of tonality or functional relations between them. So it's, for me, it's not that helpful actually in the learning process. Maybe for some visualization strategies, for, I don't know, artistic visualization or for analysis, maybe, but not in the learning process.
Okay. So I would love to go on with this conversation and these